Hi guys, today let's discuss the LeetCode question 94, Binary Tree Inorder Traversal. Given the root of a binary tree, return the inorder traversal of its node values. So inorder traversal means first the left tree value should be processed, followed by the root node, and then followed by the right tree node values. So let's go to example 1. So in the example 1, there is no left tree. So that is the reason we are getting in the output we are getting the root value as the first one and followed by the right tree values. So even in the right tree we are going to have the same order. First the left tree should be processed, followed by the root node and followed by right tree node values. That is the reason we are getting 3, 2, left followed by the root. Let's go to the example 2. So example 2 is the root is none. So in this case we are going to print an empty list. Then in the example 3 there is only a root node and we don't have any left or right tree for this. So in that case we are going to print the value of the root node. And there is a follow up to this question. The follow up is like we should not be doing this one using the recursive solution. We have to do it using the iterative approach. So let's discuss more about this. Let's discuss the steps to follow to process a tree node using iterative approach. The steps will be as follows. First, we are going to create an empty stack. Two, we are going to append root node to the stack, followed by all the root.left until root.left is none. And the third step is going to be pop a node from the stack, then process it. So processing it is like appending it to the result. And the fourth step is going to be repeat steps 2 to 3 for root.right. So only these four, if we follow these 4 steps, we can get the inorder traversal of a root node. Let's dry run with the above example. So initially we are going to create an empty stack. We are going to name it as stack. Stack is going to be empty. And we are going to store our inorder traversal result in the result. So that is also going to be an empty list. The second step is going to append the root node followed by all root.left until none. So first we are going to append 1 to this stack. Then we are going to append all the root.left until it is none. So then we are going to append 2 followed by 4. Then we are not having any, then the root.left is none. So we are not going to append anything to this stack. Then we are going to the step 3, which is like pop a node from the stack. So we are popping this node 4 from this stack and we are processing it. Processing is storing it in the results. Then we are going to then we are going to the step 4, which is repeat steps 2 and 3 for the root.right. Since the root.right is none, we are not going to process anything there. Then we are going to pop one more node from this stack. We are going to pop 2 from this and we are going to process it. So processing is storing it in the results. So we are going to store the 2 here. Then we are going to go to the step 4. In the step 4, we are going to add a root.right. So root.right, we are adding it to the stack. So which is 5, we are adding it here. And since the root.left is none for this 5, then we are going to this step 3, which is popping the node. Just pop this node from this and we are going to store it in the result 4 to 5. And repeat the steps 2 to 3 for the root.right. Since there is no root.right for this 5, we are not going to process it. Then what are we going to do? We are going to the step 3 again. We are going to pop a node from the stack. So our stack has only one node, which is 1 now. We are going to pop it and we are going to process that node. So processing it is storing in the results. And then we are going to append the root.right and follow the steps 2 to 3. So we are going to add root.right, which is 3, and append all the root.left values. Root.left is 6. Okay. And then we are going to pop a node from this stack. So we are going to pop this 6 and we are going to process this 6. Then then the next step is again to pop one more node from this stack, and we are going to process that one as well. So that is going to be 3 in this case. Now we are coming to the step 4. Repeat the steps 2 to 3 for the root.write. So the root.write is 7. So I am going to append this one to the stack, and all the root.left. There is no root.left for this 7. So we are only going to store 7 in the stack. Now we are going to pop this node from the stack and then process it. Processing it is storing it in the results. So finally, we are done. So we are going to get the results in the form of a list using an iterative approach. I hope it is clear from this explanation. Let's quickly code this up. Let's start by creating a stack and initializing with an empty list. Stack is empty list, and followed by the results, which is going to store my Inorder Traversal. That is also going to be an empty list, and followed by my current is going to be the root node. And then I'm going to loop this entire, I'm going to follow an iterative approach. Then while current, I'm going to add this current node to the stack.append current. Then current is equal to current.left, and also all the subsequent current.left values to the stack. Then if there is any nodes on the stack, then what am I going to do? I'm just going to pop the element. Pop is equal to stack.pop. Then I'm going to add this one to my result.append pop. After adding this one to my result, I'm going to update my current. Current is equal to current.write, and my else case is going to be break. So if my stack is empty, then I'm going to break away from it. I think we are done. Let's return the result. Yeah, let's quickly run the code. We got a none type. None type object has no attribute write. Current is equal to current.write. Sorry, it is going to be pop.write. Yeah. Sorry, we are going to append pop.val, not the node itself. We are going to add only the values of it. That's in the code. Yeah, it is complete. Let's quickly submit it as well. Yeah, it is submitted. Hope you liked the explanation. So for more such videos, please subscribe to my channel. Thank you.